Thank you everyone for being here. Welcome. We look forward to discussing today how corporate and commercial real estate, and specifically its HVAC, is being impacted and called upon in these trying times of the COVID-19 epidemic. As well, we will take this opportunity to discuss how artificial intelligence can be used to address the building management and HVAC challenges that we're seeing today. So on our panel, we have Jean-Simon Venn, who's the Chief Technology Officer and a co-founder at BrainBox AI. We have Sam Ramadori, who's the Chief Operating Officer at BrainBox AI. And we also have Professor Izmir Ranu, who is Professor of Building, Civil, and Environmental Engineering at Concordia University. So those are our speakers, and without further ado, we're going to get started. So the impacts of COVID-19 on real estate are clearer than ever, and many countries are really shutting down their cities, and we're actually seeing some of them starting to reopen. So Professor Izmir Ranu, to kick this off, what major HVAC issues have you observed be created in real estate by COVID-19, and what new HVAC challenges will real estate owners face as they begin to reopen their buildings?
Good afternoon. Thank you for the invitation. I will start by saying we have every day new conflicting evidence about COVID-19 from scientists, medical specialists, and experience from many countries. Therefore, I'm not able to say what will be tomorrow. I don't think somebody knows. What I can elaborate on the relation between HVAC and COVID-19 based on current knowledge and current regulations, standards, and guidelines related to HVAC systems. I would like to say a few words about the propagation. The propagation of virus goes by contact, but also by droplets and aerosols. And these two are most important related to the HVAC system. And there is no consensus about possible aerosol propagation. We heard about Princess Diana cruise, where many people got infected, assuming based on the HVAC system. However, evidence proved that was not HVAC system carrying the virus and propagating the virus. There is, however, no proof that the HVAC system will not affect. Therefore, in most cases, we don't know will affect or not. Under these assumptions, I will discuss now about the HVAC systems based on the latest recommendations from Public Health Institute of Quebec, ASHRAE, and REHVA, which is equivalent to ASHRAE in Europe. All of them published April 2020. And the recommendations related to these HVAC systems for corporate, for real estate, for all kinds of buildings should go on top of normal, regular, periodic cleaning up of systems. It's not something new. If the system is not clean, the filters are not changed, if the faults are not detected, will not help to avoid the propagation of this virus. Then I have a short list of very practical and very short list of items. First, ventilation in this system might be through effective air distribution by dilution. Why? Because the propagation goes also related with the duration people absorb the air and the density of virus in the space. By diluting, by having a good ventilation, we reduce the impact. Second, expanded operation time. It means 24/7. In some cases, in some countries in Europe, they recommend starting 2 hours before normal occupancy and stopping 2 hours after. They recommend no off HVAC system during the weekend. It means continuously running at no lower speed. What will be the impact? Higher energy consumption. Then finally, somebody must balance. But this is the regulation. These are the recommendations at this moment. Another one, air movement should go from clean spaces to less clean spaces by creating pressure differential, higher pressure on the corridor, for instance, and lower pressure in the occupants. Another one, exhaust ventilation from toilets must run continuously. Again, energy impact. Something related with mechanical ventilation air conditioning system. I think I have to. This is a conflicting evidence. Why? Because virus, COVID virus, can propagate to the air which is created by the ventilation air conditioning system. But there is not enough proof that components, the duct system, can contribute to the propagation. Therefore, if we want to know better, it would be much simpler. But now, just cleaning up continuously, as was supposed to be done, might help. I would say heat recovery. These are a very debating topic. Heat recovery will help reduce the energy bills. However, there is a risk of virus leaking, going to the leaks from the exhaust air stream to the fresh air stream, which should go in the building. In this case, can propagate the virus back in the building. They recommend, for instance, control leakage, you can, disactivation or bypass heat recovery system, which means energy consumption, energy cost will go higher. If this will be applied, we say at this moment, these are recommendations. I don't know what will happen tomorrow. Maybe everything will be fine, will be paradise, and we don't care about this. But what if this situation will get even worse, and then must be prepared at least to be aware of the situation. And last item here, before the last one, it's air recirculation. In large buildings, we have air recirculation. Why? Because if you bring 100% fresh air, the heating and cooling cost, energy cost, will go very high. Therefore, traditionally, in this all-air HVAC system, where energy, heating, cooling, and ventilation is vehiculated by air, we have about, let's say, 20% fresh air and 80% recirculation. But in the condition of virus propagation, the recommendations are to prohibit in healthcare buildings the recirculation, to provide 100% fresh air, and in the existing buildings, it's very nice to see the recommendation from RECVA. They have a very specific recommendation for existing buildings, what to do, and to close the recirculation dampers. Another topic of interest is decentralized air conditioning system. I'm talking about fan coils, window type air conditioning system, air conditioners, variable refrigeration flow, the cassette type. What is the issue? The issue is, will recirculate the air in the room if there is only one person in this healthcare space, then there is no problem. But there are more than one. By recirculation of this air, by this decentralized system, may propagate the virus to other patients or other occupants of the space. And now the problem is, this system, if we cannot turn off the system, they must run continuously. Outdoor air filtration, and this is the last one. Outdoor air filtration, outdoor, normally, this is what experts say, we don't have viruses going at 10 meters, 20 meters high. Then the fresh air is not supposed to have viruses. Therefore, there is no reason to put additional filters. On the other hand, the recommendation is, if we still use recirculation, we need to have 2 levels of filter. First, a pre-filter, MRV8, for instance, plus HEPA, which this involve additional cost. And now, after I presented this kind of issues related to the impact of COVID on HVAC system, what we have buildings, hundreds, thousands of sensors. Every sensor can bring 1,000, then you have 100 millions of data points every year, and nobody's able to handle this by hand or just looking to the screen. Then we need dedicated, automated, ongoing commissioning software. And here, artificial intelligence, machine learning techniques can have the additional impact we need. But again, automated ongoing commissioning or existing building commissioning, this could be done and should be done regardless of COVID. COVID-19 will force us to have an additional dimension, additional applications to this ongoing commissioning software. And regarding this intelligent machine learning techniques, I'd like to give you my own perspective here. I will compare this kind of system, automated dedicated system, to a human nervous system. Then we must have a system installed in buildings which would behave like a neural nervous system, would be able to collect information through sensors. We have sensors on our skin called cold and warm sensors. Cells in the building have sensors, all kinds of sensors. To be able to collect these sensors and go to the brain of the automated system, which will do all kinds of data analysis, data storage, data processing. But do we have this capacity? And therefore, what is most important at the very end is to have an application called knowledge extraction and use. We extract all these millions of data, and AI or machine learning will be able, done properly, to extract the information, past experience, past history, and extract knowledge, and propose actions, forecasting, FDDs, and so on. And the last point, and the video I finish now, the last point is, in addition, if you want to go somewhere in addition to what the brain does, to have connections with different applications. For instance, an application of IoT. This would be something. Application of edge computing. Application connected with Hydro-Quebec or any other utility companies, with the Environment Canada, to forecast the conditions and to work on this, or any other applications. I think it's a huge empty field. We just started to work in HVAC system with this kind of techniques. AI and machine learning is a huge, very huge domain. Yes.
Thank you, Professor Smeranu. Those very insightful listing and great introduction to AI and the impact that it can have. Wondering if we could just delve in a little further with regards to the challenges of HVAC. Do you see there being any sort of difference between how those challenges will exist in the commercial real estate, like retail stores, versus corporate real estate, like huge office towers? Could you speak to that a bit?
Yeah.
We lost Professor.
Yeah, I think we lost him. Okay, so that's okay. We will move on to our next panelist, and perhaps we'll have a chance to loop back around when the professor has a chance to re-sign in. So Jean-Simon, I'm going to go to you now. It's good that the professor left us off on AI, which is very relevant to your section. In real estate, the technology that's said to hold a powerful key to resolving some of the issues that the professor has mentioned is artificial intelligence. Can you tell us more about how AI can help building owners address some of those challenges, Jean-Simon?
Yeah, and actually, Rebecca, I might go a bit larger because I think it's interesting to see what's being done right now in the AI space around COVID. Um, and when you do like a big tour of the garden, you kind of see there's like three major area where people are trying to apply AI to either protect or warn or to help us manage this crisis. The first area is investigation and kind of personal warning system. And that's a bit on the big brother. It's a bit freaky. There's a lot of discussions. I'm going to cover that. Then there is the facility protection, the real-time facility protection. How can we protect people which are using some of our buildings? We still have to go to the grocery. And the third one is the protection strategy. So what decisions should we take? So these are the three big area where you see a lot of movement right now on AI, either development or application to specific issues. So let me tackle them one by one. The first one, investigation. This is, you saw all the article. These are the phone apps application. So I did a quick scan. There's already about 100 company coming with their COVID phone app application. It definitely a race, which one the government will choose to implement. Already most of the government did not bid out a big ethical debate. They went directly to the decision. They will use some of these applications. So the race is on as which one. And there's very little validation done on who's going to control what data and who's going to have access to that data, and that's why it's triggering all kind of debate in the different journalist article that you may have seen. So why are we going there? Well, the goal here is to have these apps which are recording or localization, and then sharing that information with an higher cloud application would basically know whom did you went very close to in the last 2 weeks. And you have to go back to how it's done today. So today, you are positively identified as COVID, you are sick or not sick, but you are positive. Then they basically try to figure out who did you see in the last 2 weeks. And they're gonna try to trace back to warn these people that, oh, you did meet with this person, which is now positive, so you should go have a test because maybe you are positive, maybe you were infected when you saw that person. And that's something very particular with the COVID, is like that 2 weeks of you're basically infecting tons of people and you don't know that you're sick yet because you don't have any sign yet, but you're infecting people. In 2 weeks, even if you put like 2-3 investigators that are trying to figure out, let's build a list of every people that you saw in that 2 weeks. It's a big job. It requires several government employees which are trying to make that puzzle back together and then contact these people. So the goal of these apps is to basically register everybody you're seeing by seeing this proximity. And it's pretty easy because both Bluetooth of each phone would be in a range to basically say if you were close enough to get infected. And then they build these lists. And as soon as you are confirmed positive, they just pull out the list of everybody within a few minutes, and they know exactly, and they could actually reach back these people by just sending a message on the same app. So these people are warned that, oh, by the way, we're not going to tell you who, but you were very close to somebody which was just declared positive. And then you should go take a test. So suddenly, instead of putting 2-3 employees of the government trying to figure out that list, it's kind of done automatically and very efficiently. So of course, it required that you say, yes, I want to share my location, real time, all the time to that body, and who is that body. So that's why it's triggering all kind of ethical debate. So we will go through this. Definitely the governments already said, yes, it's going ahead. I think the key question is which company will supply these type of app and who's going to control the data. And that's, I'm sure, is going to be fueling all kind of debate in the next 6, 7, 8, a year, month. Quite interesting. The second area, which is the facility real-time protection area, this is a word that I think it's even more fascinating than the apps, because the apps is the app at the end of the day. It's using the phone and mostly the camera. So you saw the thermal camera. So now some government will say, if you want to get in that building, we're going to have to take your temperature. And that's going to be the screening process. So thermal camera will be used. It's already being deployed in several grocery stores in Ontario, where basically they scan everybody coming in. And then the key aspect of AI is to detect, based on your thermal image, if you have fever or not. And it's not a very easy question to answer, because some people are by nature a bit too hot, and that doesn't mean they're infected in any way or shape or form. And then you don't want to basically reject them from accessing that grocery store. So there's a lot of AI going on being able to make sure that when we see somebody a bit hot, at the right place. I mean, where is it hot? On the cheek, on the front? I mean, where is it? Is it the nose? And basically being able to derive if it's that fever or not fever. So you're going to see that, of course, in airport. Already Air Canada mentioned that they will take your temperature as you're checking in systematically. And there's word that they might do it mid-flight. So you're going to have that travel in the middle of a plane. They're going to take your temperature to make sure that you're still okay, because especially like these long flights, 7-6 hour flight. So this is the new world, right? So you want to make sure that you're not doing like a wrong reading, saying, oh my God, this person has fever, and really does not. You imagine the chaos it creates if you do a false call like that. But what's very interesting is these camera which are not looking at the infrared image to see if you're doing fever, but trying to spot advanced sign that you're gonna be sick. And there's a lot of research being done on your eyes. So the way our eyes are moving, and the way we're touching our face. And it seemed that there's an interesting correlation of these behavior, which are leading to early sign that you're getting sick, but there's still no clear symptom of it. So this is very interesting, because it can give you a collection of these signs, and as soon as you have the critical mass of these signs, it will call the shot and saying, you are about to get sick, so we don't want you access to this location. So you're gonna see these type of camera, like really looking at eyes and our hands. How do we play with our hands? And it's a fascinating field, because it's pushing the science quite rapidly as we speak. Another application of camera in protecting the facility in real time is watching where people go in the building. So let's take this example of the grocery again. Everybody's going and touching the breads. They're not supposed to, but they're touching the bread. So you want to know that there is a lot right now of traffic on the bread department, the bakery department. You want to maybe send somebody to clean it up right now. So right now, the way it's being done is, let's say, they're cleaning the doorknobs every 15 minutes. So there's an employee, their dedicated job is to go clean with that alcohol liquid, the doorknob, every 15 minutes, no matter if there was people there or not. So now with the camera, they're going to basically tell that same person, don't go clean up every doorknob every 15 minutes, but you should concentrate yourself in this location and clean these doorknobs right now, because they were just used. And these other doorknobs, really, they're not used right now. Nobody touched them, so don't need to go clean them again. So concentrate where there is a need to clean these facilities. So you see that happening. So imagine the grocery store, they will be basically making sure to where should they go clean in real time based on where there was traffic and no traffic. So that's one aspect. The other aspect, you saw these security guards. So we're right now putting buddies, right? So we're putting these security guard to make sure there's no more than 50 person at the same time in that grocery store. And basically the security guard is there to make sure people are washing their hands, and that we don't have them exceeding that maximum capacity, which was called by the government. So the same thing could be done with camera, where you have that camera, which is basically telling you, yes, there is that many people right now in the store, and you're okay, and you could allow another one to come in or not. So you're automating that function, but at the same time, you're automating the function that did they wash their hand or not. So you want to have that movement, and it's long enough, and then you might have a voice telling you, no, you did not wash your hand long enough, do it again, I'm not going to open the door for you. So these are the type of AI application which are really aimed at going at protecting the facility in real time. And the last area is what I call the protection strategy. So it's really the big data as we know it. So the big data as we know it, we're starting to have a massive amount of data right now. In the United States, people infected were slowly reaching that 1.8 million people. So that's a lot of data, and it keep growing day after day. So having that data, we could start now to predict where is it going to go next. So now we're reaching back to a situation like here in Montreal, where we're starting to be good enough at the data that we could tell you which CSHLD will be infected next. What's the next building that will be infected? Because we see the propagation and we see how it's propagating from one building to the next. So we know what is the risk level for the next area that will get contaminated by the behavior of people and the way we're using that data to analyze how it's propagating. So that could be used to basically help the government to know what should you open next. Is it okay to open camping next? And yes, which camping? Or this camping, no, it's more at risk than this other camping. So it will help the government to take decision about what should you confine, deconfine, when. So you're gonna see that happening until we have a vaccine. So these big data prediction engine will tell the government, you should reconfine this city or this type of building, and you're now okay to open this other type of building in terms of confinement and deconfinement. And now that we have enough data, it's becoming more and more accurate. Of course, places where there was no infection at all, we're in the dark. We're not going to be able to have to apply this type of AI technology. But a lot of places where we now have a lot of data to do it. So that kind of covered the big area where AI is flourishing right now.
That's amazing. It's a great list, and it's quite impressive to see everything that's going on. But a lot of us, are thinking at some point there will be a vaccine. At some point, this epidemic will be over. What are your thoughts as to how AI will continue to provide support to buildings and building owners post-epidemic?
Well, I think it goes back to the risk level, right? So knowing what is the density of user in a building per floor or per zone, it gives you the risk level. So the more data, as Professor Radu was explaining, the more data we have on the scientific side about how this thing propagate, we could feed that data into the AI model, which then in turn will try to identify what is the risk level based on the density of people. And remember, all of these apps are generating a lot of data. I mean, we don't need to know who it is, but we do just need to know how many people there is in a location. And having that data coupled with the latest research happening, and I might just open that parenthesis. I mean, right now there's so many scientists working on the COVID. It's unseen in the history of mankind. I mean, and they're all publishing at a rate that nobody saw before. So if you just try to do on a daily basis, read all of the paper published on COVID, you will not have enough hour in a day to read it all. So you need to build a team to read all of these papers and try to extract the key data point to then implement that into a neural network. So you could basically try to see, okay, if I have that many people there, based on the latest scientific fact that are coming from these research, what is my risk level? And how should I manage the building knowing that risk level? If your risk level is starting to increase on a daily basis, as a building operator, you're gonna have to take the decision, what do you do with that increasing risk, which is growing, or is it decreasing? And that's another interesting aspect. Should I permit more tenants to come back in? I mean, and it's really, really a moving target right now.
Thank you for those insights, Jean-Simon. I think this leads logically into the next panelist, which is Sam. And clearly, Sam, there's a lot of impressive stuff going on in AI. Our world, the BrainBox AI world, is about bringing AI to HVAC. And recently you released an article where you shared BrainBox perspective on the 4 stages of COVID-19 building management crisis. Can you tell us more about each of the stages and how Brainbox AI's artificial intelligence methods can support building owners through those 4 stages?
Sure. Thank you. Thank you everyone for joining us. We've all gone through a very interesting period in the last 2 or 3 months. It's clear, obviously, no one could ever have imagined the situation we're in today and what we've had to live through over the last several months. We have lived those moments with our customers and have lived live firsthand how they've had to react. And so the reason behind the article was just to lay out the experience over the last few months and talk about how we've tried to support our customers along the way and the realities they face. So to be clear, most commercial buildings are meant to be very, very forecastable, static operation type situations, and everything around in the building, including the HVAC system, is designed with that stability and ability to program around that use in a pretty efficient way. And let's consider that basically all of that has gone out the window. So no one expected to have a building that's 90% occupied go to 10% occupied within a matter of days or a week. So that's the initial stage of that situation, watching the building empty out very quickly. And then have the period where the building is empty, but in too many cases, it's actually not most buildings that are 100% empty. In many cases, there were essential services, businesses that continue to operate, or even on a skeleton staff. So it wasn't even 90% to 0, but it was 90% to something like 10% or 20%. And that occupation was very sporadic. It wasn't the top 10 floors out of 30 floors. It was, floor 18 and 19, second floor and the 7th floor. So it came quick, and it came in a very unpredictable fashion. And that I think was stage 1. And in various cities, I guess that lasted or continues to last kind of week by week. And then I think many of us, and that is the case here in Montreal, we're living through the repopulation or the reoccupation of those buildings. And again, it's the same experience, which is as the regulations open up, allowing for reoccupation, it's very case by case as to how companies are reacting. We've seen, companies say, no, we're not going back till September, regardless of what the government regulations say. Some people have even pushed it out to January, and some of these are major corporations, especially here in Canada, that we've lived live. And so then you have a reoccupation that is not regular, but then again becomes multiple floors here, multiple floors there. And so this whole experience to swing from normal down to mainly disoccupied and then back up to partially occupied, and that's going to vary as well. And we'll get into the situation when we think of a potential next wave. But all of these things, I mean, if we sit back and think how buildings have traditionally been optimized, you have a base control sequence put in place, when the building was built or recommissioned. And as best you can, traditionally that control sequence and the efficiency kind of parameters built into it are based on averages of temperatures in a season, averages on occupancy schedule, and as best you can, you're programming to be most efficient around those averages. And already that is a difficult thing to do, because unfortunately, you may pick the average temperature in a season, but in any given month, that average temperature or average day only happens once or 2 or 3 times. So already in the best of all worlds, you're probably trying to optimize, but even then it's not perfect. And let's go layer on top of that an occupancy level that is swinging up and down very dramatically and in a fairly unpredictable fashion. And then it's sporadic. Again, it's not the bottom 20 floors that start to be occupied. It's floor here, floor there, floor there. And so you're pulling on centralized pieces of equipment that are having to provide chilled water that are not used to that and are not designed that way. And to try to forecast the demand or to manage that demand specifically in a very dynamic where it's changing by week, and it's virtually impossible. And I think that's where we've seen the benefits of having something like artificial intelligence, where the reality is the analysis capacity is not to say unlimited, but it is huge. Just in a regular building that we plug into, the amount of computing we're doing at every 5-minute cycle is off the charts. The reason why we do all this in the cloud. And so then when you think about all these swings, there is a real advantage to having that computational power at work every day in your building. And if you have to modulate it by adding several floors or opening new zones or playing with the air changes per hour as are mandated by regulations or suggested by various organizations, again, to do that by hand, you'll make that change, but good luck it being optimized, right? It really, and by the time you have to change it again next week, you will have no time to do the analysis and optimize. So in our case, having the AI agent there really constantly optimizing relative to the changes that you're bringing. So one, having it there to implement the changes and setting new targets. And then at for us, it's 24 hours a day, 7 days a week of optimization, every 5 minutes, recalculating the optimal settings. You're able to make those changes and then know that the AI agent is doing its best to optimize in that new scenario. I mean, we all know if you're going to dramatically increase the air changes per hour, your costs are going up, period. But there will be a difference between just opening the floodgates and running it that way versus giving new targets in terms of air changes per hour and then having the AI just constantly and autonomously optimizing to that situation. So that's certainly what we're seeing, and we've also the benefit of AI. Our core product is something that optimizes to energy consumption and occupant comfort. But it is an AI agent. If you wanted to optimize to another target, you can do that. You can program that, and that's what we've tried to do through various other solutions we've presented, including the airborne virus mitigation program, where again, looking at the standards that are put forth by ASHRAE, the CDC, and looking at those targets and being able to implement those targets in a building and in a most efficient way possible. So really it's bringing that capability to a system that wasn't designed at all to be flexible, frankly, flexible or adaptive. It was HVAC systems in commercial buildings are meant to work off of a schedule and a pre-programmed control sequence. And now, bringing the capability to be adaptive and constantly learning and then constantly optimizing autonomously the building is really advantageous in this kind of environment. And look, one last point, and Professor Radu pointed it out very clearly. We already today don't have all the answers, or frankly, many answers, and we're learning as we go along. And there's stuff we don't know. We're opening up again. It's positive to see that trend, but I think if you ask people the risk of having a second and a third wave and how big those waves are they little waves we can live with, or are we going to go back to having to implement a shutdown in a city? These are all unpredictable events. And again, having the capability of having that AI agent guiding you along all of those changes and implementing those changes when they come up as something that we've seen a lot of interest in. So
awesome. Thank you, Sam. We will move on to the question period time, and I see there's a few people that have already put some questions in the chat. If you have any right now, feel free, we will get to them. So to kick it off, the very first question that was put at the very beginning, before we get started, Professor Esmiranu, are you back with us? Can you hear us? Can you?
Yeah, I'm back. It was just a bug somewhere.
Okay, no worries. Glad to have you back. I think this first question would be great for you. Coming from Frank, will 100% fresh air requirements get reduced post-COVID-19 vaccine? Or is this the new reality?
Okay. I would like to mention these are recommendations and guidelines. They are not yet in national codes or in local codes or in bylaws. Therefore, in order to reduce, experts in the field, medical doctors, not HVAC engineers, recommended to avoid recirculation than to use only 100% fresh air in the building. Now, this is a weakness of the all air systems we have in North America, where you have recirculation and fresh air. In other parts of the world, all air systems are not largely used. Therefore, for the past 10 years or so, we are talking about dedicated outdoor air systems, where you provide only the ventilation using a vector, the air, while heating and cooling is provided by other means, other vectors, such as chilled water, hot water, refrigerant. And therefore, the impact will be different on these systems compared with what we have now.
Great. Jean-Simon, Sam, anything else to add?
Nope,
Perfect. So, well, next question, I think, Jean-Simon, this one's a good one for you. How does the constant changes being made to HVAC components, dampers, for example, position, affect their life cycle? Are they made to withstand it?
Well, that's,
Yes.
you know, you have to, absolutely, you have to be very, oh, sorry, Professor
Okay, go
Raj.
ahead, please.
I mean, if you want to go ahead.
Yeah, go ahead, please.
All right. So yeah, basically, that's where things get complicated. So to readapt, reconfigure systems to follow these new guidelines, as Professor Raju mentioned, you would need to basically bring configuration team, so your control contractor to reconfigure, rebalance your system, implement new control sequence so the system could operate into this new design. Because really in the last 30 years, what we tried to do was completely the opposite. We were trying to follow the building code, take the outside air, following the minimum requirement by building code, so we could reduce the energy. So you don't want to take too much because we want to reduce how much energy do we need to heat up or cool down that fresh air coming from outside if it's not the same temperature than what you have inside. And then we were trying to slow down the circulation to follow the building code, but not really more than that because I'm going to save that fan energy, right? So we've been working very hard in the last 30 years to slow down that air change, still follow the building code, but to optimize the energy spending and to take just what we need from outside, not too much, unless we could do fresh cooling, free cooling. And now suddenly we realize that, oh, wait a sec, there's doctors saying, the CDC is saying, ASHRAE now saying, try to go 100% fresh air. So you would need to bring that team in and say, forget what we've configured for the last 30 years. Now I want to configure it this new way. And they will do it, but you need to do it so you respect what the equipment is capable of doing. So you go as far as the capacity of the equipment. So maybe you cannot take 100% fresh air because you will not have enough heating or cooling capacity to maintain your desired temperature in the room. So you go as much as you can with the limit of the equipment, and at the same time, you don't want to burn your equipment. So you need to respect the normal operation of that equipment that is defined by the company that manufactured that equipment. So you need to take all that into account and rebalance your building. But then again, that is true when it's a certain temperature outside. If it's another temperature outside, you could maybe take more fresh air because it's not that much to readjust in terms of heating or cooling.
Jean-Simon, I'm going to interrupt you. Our question asker has made a specific comment. The question is pertaining to AI instructing the HVAC.
Yeah,
in terms
so sorry,
of it.
I was getting excited here. So, so basically, yeah, you want to use the AI to modulate that in real time to find what is the right balance for the equipment operation, for the outside air temperature that you have right now, and trying to maintain that desired temperature in the room and try to tend as close as possible to the recommendation of the ASHRAE or CDC. So that's how the AI is capable to learn and readjust itself all the time in real time, and you don't need to bring a team of outside control technician to recommission your building.
And how does the AI, I think the question is, when the AI is instructing constantly dampers to change their positioning or, to equipment to differ constantly, will that affect the life cycle of the product?
Yeah, actually, AI will try to reduce that on-off or that movement as much as possible while obtaining what you desire.
Yeah. We would say our experience since we've been installing is that we get that question under the core product of energy optimization. We often get that question, but when you see the trend logs, the charts, you'll see that the AI is reacting typically far less frequently than the current system. And that stems a lot from the fact that the AI is predicting the future. Today's HVAC systems don't know what's going to come in the next 2 minutes, 5 minutes, right? Whereas our AI is giving the visibility in the next 1, 2, 3, 4, 5 hours with over 99% accuracy. And with that visibility, it's optimizing, but it doesn't mean it's turning on and off equipment more frequently. It's actually doing it less frequently. It just because it can see the future, it's doing so more intelligently.
If I say a word here, in addition to what was said before, at this moment, I'm okay?
Yes.
No, I'm okay.
Yes.
Currently, we have so-called demand control ventilation system, where we have a sensor monitoring the concentration of CO2. It's easy. And then we, based on this, we are able to increase or decrease the amount of fresh air brought in the building. But right now, we don't have a sensor for COVID-19. We don't have a sensor for SARS. We don't have this kind of sensors. But if in the future, let's dream, if in the future we'll be able to have these small chips and we can select in Canadian Tire, we can select the chips we'd like to have, then at that moment, maybe we don't need to have 100% fresh air because we can control and verify what is the real impact. But it's a long shot for our dreams.
Understood. The next question I think is a good one for Jean-Simon. It's a bit lengthy, so bear with me. Larger ACH air change per hour ventilation can dilute the COVID-19 virus in air. However, large ACH will blow virus in wider area. Now, there's no evidence to show the risk of virus concentration. Therefore, we cannot define a good ACH now. Is it possible to define a precise ACH which can have lowest risk by AI? How can big data be used to collect that information? Yes, Professor.
May I respond to this one? This is a very relevant question, and I will say no, we don't know. What is the issue here is more ventilation air in, I believe in Reconfiguring or in Quebec, it's say 6 air change per hour. I'm not talking about 100 air change per hour, which will blow all papers and everything. I'm talking about 6 air change per hour. Now, if what will be the impact if we increase the ventilation rate? How these viruses will dilute? What will be the impact on the health? Nobody knows at this moment. There are studies currently in University of Alberta in BC, and we start a study also in Concordia with Professor Leon Wang, Quebec and Natural Resources Council, to simulate, to see the impact in rooms, on different rooms of ventilation, how the particles, the viruses will move, how they will dilute, and how the pattern of movement at different air change per hour. Now, they should be, once we have this CFD modeling, we can find out stochastically what will be the position of different viruses. But the rest is medical part. At a given concentration, what will be the impact to get the sickness? Therefore, at this moment, in short, no, we don't have. Nobody's recommend to have very high airflow rates. They would like to have a continuous ventilation, not low flow rates.
Great. Another question, Jean-Simon, this is about the technology, so I think this is a good one for you. What are some of the data privacy measures taken by BrainBox during the AI model training system? Does the model training take place on the edge device or on the cloud?
Yeah, so absolutely. The training is on the cloud due to the computing capacity that we need. The edge is more on command and control. So there's low processing capacity on the edge, and we're respecting that hardware limitation. The privacy is we're collecting basically all of HVAC control data points. So we're talking about temperature, we're talking about damper open position, we're talking about stage heating, fan speed, valve position, pressure, and pipes. So this data is collected in the cloud, encrypted when it's in movement, and encrypted at rest in the cloud, and is segmented one database per building. It remained the ownership of the customer at all time. We just have the right to use it. So it's we're not collecting like personal information regarding a phone position and these type of information. We want to make sure we're not having any type of data that could be a problem. But even if HVAC data is not really an issue in terms of privacy, we're keeping it as is it was at all time.
And these practices are the same regardless of the AI being in the training phase or in the deployment phase, correct?
Yeah, always. Everything is segmented per building, encrypted.
Perfect. You have a thank you, Jean-Simon. Does anybody else have any questions? We've gone through the list in the chat. We still have about 5 minutes with our panelists. I'll give it an extra minute if somebody's typing out a final question. If not, we will conclude the webinar. So just give it a few more seconds. Again, as I mentioned at the beginning, for those of you who want to rewatch the webinar or didn't have a chance to watch the whole thing, we'll be sending a recording link, a link to the recording via email. And you can share that link with others, and you can obviously use it for yourself. We have another question. We have 2 other questions, actually. So this one is about AI. AI can operate the HVAC as close as the guideline for combating the virus. However, the capacity or ability of the HVAC in previous may limit the effects, since current HVAC is not designed for the virus. Will the AI be used for designing the HVAC for specific purpose?
Can I say a few words? Yes.
Sure.
Okay. Now, of course, I don't think so would impose some drastic changes to operation of the systems to increase to 50 exchange per hour, which means all buildings in big cities must change overnight. I don't think this is the purpose. The idea is to give a guideline how to move towards a better operation, and in the case of existing buildings, and especially for new building design, what should be done. But keep in mind, we don't have the proof yet, the experience to set the minimum air change per hour required by this HVAC system.
Jean-Simon, anything to add to that?
No, absolutely. I mean, it's something. I mean, just had a story. We deployed the COVID-19 algorithm in several buildings, and we are limited by the capacity of the existing HVAC. I mean, yes, we would like to have 100% fresh air, but if in a day like today, when it's humidex in Montreal of 37 Celsius, I mean, you do open that damper 100%, your cooling capacity will not be enough to bring that air down to that 22 or 23 degree that the occupant are expecting. So, I mean, you can't open the damper 100% today. Sorry, it is what it is. So you're limited by the capacity of the equipment.
Great. Another question for Sam, I would think this time, from Kevin. Is there a service limit or square footage capacity per box?
I'll say broadly speaking, no. We've deployed our boxes in building as small as 10,000 square feet and as big as over, I think, 2 million square feet. So no, a lot of the computing power, computational power is in the cloud, and as Jean-Simon mentioned, the box is the mechanism by which we're transferring the data to the cloud. So usually the box is not the limitation.
Great, and perhaps a combo of Jean-Simon and Sam on this one. At high level, how do you connect to the HVAC systems?
Do you want me to do it, Sam, or you want to do it?
Please do.
We connect to the existing control system. So most of the big control systems, we build a library to connect to them. So think of Johnson, even Honeywell, Distect, Schneider Electric. So we basically come and we connect our edge device to the existing control system, and our box start to talk the same language in that control system. So we're not creating any problem on that existing control system. And then we start to, first of all, read the points for a few weeks. When we have enough data to learn, we start to basically write back on some of the point, which is the control strategy, which is applied directly from the AI. And the box is connected to an encrypted connection directly to the cloud using a SIM card, which is we find as the most secure way to connect the box to the cloud.
Great, thank you. And I will look out, if Danny, if you have any follow-up questions to that. Another question that just came in, how quickly could an algorithm be developed to match UV output to occupancy? Jean-Simon?
That one's definitely yours, Jean-Simon.
I was thinking that Professor Radu maybe.
Thank you very much. No, I don't know.
It's a tough question, yeah.
I don't know either. I mean, we're give you an example. We're working now on algorithm which are working on the dew point for grocery stores. So it's always for us unknown. Try to figure out how long will it take us to develop that dew point optimization algorithm. So it's unknown. This is part of research, right?
Perfect. Great answer. And then our last question that is a bit off topic, but perhaps will lead to another secondary discussion. Do we have a distributor in South Africa?
And I've just noticed that that came from the person that in the tile has a picture of the elephants in their in their Zoom tile. So I know at the moment we do not yet have an installation in Africa. I think we've got a few other continents covered and growing, but at the moment we have not yet installed in Africa, but looking forward to it. Great.
That's the end of our questions. So if you have any other questions or looking for more information from Jean-Simon, Sam, or Professor Zmiroanu, you can write to us at info@brainboxai.com. We receive all those emails and we respond very quickly. And would just like to thank the panelists. Thank you for your time. Thank you for your answers. And thank you to everyone who participated. We look forward to meeting again in the future. Thank you. Have a good end of day.
Thank you, everyone.
Thank you.
Thank you, everyone.